To find the normalizing factor, we need to find first the magnitude of psi squared for n sub x, n sub y, n sub z of x, y, z, and that would equal the square root of c squared times sine squared n sub x pi x over L sine squared n sub y pi x over L y, sorry, over L, and sine squared nz pi z over L. And that means now that the normalizing factor, we can use the equation, the integral of psi nx ny nz of x, y, and z quantity squared dv has to equal 1, which means the triple integral of, we can take c squared outside of the integral and say that we have from x equals 0 to x equals L, y equals 0, y equals L, z equals 0, z equals L of sine squared nx pi x over L sine squared ny pi y over L sine squared nz pi z over L dx dy dz. And let's look at just one of those, and let's look at the identity from trig that says that sine squared theta equals 1/2 1 minus cosine 2 theta, and let's let theta equal nx pi x over L. Then after you plug this in to a computer, or you can look up your tables, or if you're comfortable enough with your methods of integration from Math 227 at BBC or Calc 2, you can find out that this comes out to L over 2n x pi times nx pi x over L minus 1/2 sine 2nx pi x over L. And a further simplification of this will give us x over 2 minus L over 4nx pi sine of 2nx pi x over L. And if we evaluate this between zero and L, the integral of x equals 0 to x equals L would equal x minus 2 over L over 4 pi n sub x times sine of 2n x pi x over L, evaluated between 0 and L, would just give us L over 2, because the sine of 0 is 0, x is 0, so we only get the contribution from L, and we get L over 2. Sine of 2 pi anything is going to be 0, so we get L over 2. And now we can say similarly for the y and z integrals will yield the same thing. Therefore, our normalizing condition would be c squared times L over 2 for the x, L over 2 for the y, L over 2 for the z has to equal 1, which means that c squared L cubed over 8 equals 1, or that means that c equals the square root of L cubed over 8, which we can rewrite as L cubed over 2 cubed, and then we write this as L over 2 to the 3/2 power. So either one of these ways will work. Now for part B, we have the same y and z integrals as in part A, but now the limits of integration have changed. So the probability is going to be the integral from x greater than or equal to 0 to x equals L over 4 of psi of nx ny and z squared dv, which is going to equal c squared, the integral from x equals 0 to x equals L over 4 sine squared nx pi x over L dx times the integral from y equals 0 to y equals L over L time of sine squared ny pi y over L dy times, and I don't have enough space to write it, so I'm going to write it down here, the integral from z equals 0 to z equals L of sine squared nz pi z over L dz. We know what the result of the integral for x is. It's given by, it's going to be c squared x over 2 minus L over 4 nx pi sine of 2 nx pi x over L evaluated from 0 to L over 4 times our L over 2 for the y integral, L over 2 for the z integral. And now we know what c squared is. C squared is 2 over L c squared is going to be L cubed, or L over 8 L over 8 when we plug L over 4 in there, minus L over 4 nx pi times the sine of, when we put L over 4 over here, we're going to get nx pi x over 2. We still have the c squared up front times L squared over 4. And if we do this, we get, remember what c squared is. Oops, I made a mistake. C should be 8 over L cubed. So let's switch these around, folks. So c squared will equal 2 over L cubed times L over 8 minus L over 4 and x pi sine nx pi x over L times L squared over 4 and that will give us 1/4 minus 1 over 2 nx pi sine of nx pi over 2. And continuing with the given values for case 1. And x equals 1. That means that p is going to equal 1/4 minus 1 over 2 times 1 pi times sine of pi over 2, which is 1/4 minus 1 over 2 pi, or 0.019. For case number 2, we're given that n sub x equals 2, which means p equals 1/4 minus 1 over 4 pi sine of pi, which is just 1/4, or 0.250. And lastly, for case number 3, we're given that nx equals 3, which means p equals 1/4 minus 1 over 6 pi sine of 3 pi over 2, which is 1/4 plus 1 over 6 pi, because the sine of 3 pi over 2 is minus 1, which will give us 0.303.